Hi everyone, this is Nathan from Snap and welcome to another of our Snap XMP webinars. Today we're going to be looking at using weights and rim weights within your survey projects. It should take about 30 minutes and as ever there's plenty of resources available on our support hub which I'll be pointing you to at the end. We'll begin with a quick orientation of terminology as today we have weighting and rim weighting, but it's also worth noting that in Snap we use weights as a way of scoring data as well. We can also weight using two different tools, so we'll talk about the differences, and more than anything this is to make sure that those of you who've been using Snap for many years, you're aware that rim weights can be used where you would have previously used standard weights. For me, a big part of today is about making sure that you understand what weighting's actually doing to your data and more importantly, pointing out when it shouldn't be used or I guess the implications of using it. Having got the important stuff out of the way, or some might say boring stuff out of the way, we'll be looking at building some weighting matrices using both of the weighting tools, and then the bit that we actually want to get to is then applying these weights to your analysis. And that could be to individual tables and charts or applying the weights to a full report. A few key benefits to creating weights, or more than anything some key reasons for using weights. Correcting sample bias, so under and overrepresented groups may have occurred based upon how you conducted your survey. Was it offered only as an online survey? Was it easy to complete on mobile devices? Have you ended up with too many younger people and not enough older people? Allowing for comparisons against known datasets, so it can be useful to compare results against another organisation, perhaps a national average, maybe last year's data. But the issue we often have is that our survey population breakdown doesn't quite match that of who we're actually comparing against. Weighting allows us to match up our demographic groups more closely so that we can get some like-for-like comparisons. Giving smaller groups a voice. An example of this might be an attempt at interviewing every single person who identifies as disabled to allow you to look at their results separately, but in doing so you'll then end up creating a sampling bias as we mentioned before. Weighting allows us to collect as much data as we possibly can get, but then to effectively downgrade the impact that that data has against the rest of the data. And then finally we have that it allows for simplified analysis. Now, whether this is the right thing to be doing or not, I'll leave that for you to decide, but it can be really annoying giving your results out and having to report that these are the results for 49 men and 52 women. So weighting just allows us to give the data a little bit of a shake, meaning that we can then present the data as though we'd received the views of a 50-50 split. As I have just said though, and this applies to all weighting, we are essentially shaking our data, so how and why we use weighting needs to be given careful consideration. Okay, let's head into the software to take a look at some of the things that we've been talking about. We're going to be using the All Good Hospital Admissions Survey today, which has 160 cases, so I'll just open that one up. Not going to worry too much about the content of the survey, but we will be focusing today on the demographics section, and today I have question 11, which is the gender question, and question 12, which is the age question. I'm just going to quickly create a table so you can see the data that we're looking at today. So we have question 11 with question 12. Before we go any further, to keep things nice and simple in terms of my maths today, I'm going to be using some very outdated gender questions throughout today's webinar. I am fairly good at adding two numbers together, but I do start to slow down once we start calculating 5 or 6 figures. Now, running a survey is all about collecting data and gaining insight from your audience. The issue we often come across is that the people we have had responded to your questionnaire isn't representative of the population that we're trying to gain insight from. By this, I mean that your population may be a lovely split of 50% under the age of 40 and 50% who are aged 40 or over. But when you come to look at your data, you realise your collected data set is actually 10% under 40 and 90% 40 or over. So in short, your feedback is going to be heavily skewed towards the views of the over 40s. If your questionnaire was based around asking what time they wanted to go to bed, and I'm heavily stereotyping here as I will be throughout the day, it's likely that you're going to deduce that your population like going to bed at 8:30 and they don't drink tea or coffee after 2 o'clock in the afternoon. Again, throwing some more stereotypes out there, I dare say that if every single person had responded, the average lights out time might be a little later than 8:30, and quite a few members of your population are drinking cans of Red Bull morning, noon and night. The fact that we have under or overrepresented demographics in our respondent data is what's known as a biased sample, and there's various reasons why we might end up with this. Some examples include your chosen time, date or day of the week that you choose to interview. Even the time of year can affect the likelihood of whether people might respond or not. If it's face-to-face interviewing, where you chose to interview. And if it isn't face-to-face, where and how did you make the questionnaire available? How you interviewed. So was your survey only available to people via a QR code? Did you offer a paper alternative? Was there an option to complete the questionnaire in different languages? And did you chase up non-respondents? And if you did, was it just a case of using the same method that you initially tried to engage them with, or did you try a different tact? Now, even with the best will in the world, we often still end up with a biased sample, and that's where weighting can be used to reduce that impact. Weighting is used to scale up or down your various demographic respondents to get a better match to your target population. In short, we give a bit more power to the underrepresented groups and a little less power to the overrepresented groups. So it might be that each of your under 40s that have responded have the power of perhaps 1.2 people, and for each of the people who responded that were 40 years or over, they have the power of 0.8 of a person. In my example, I'm going to be giving different levels of power to my respondents based upon their age groups because I want to end up with a split of 40 respondents for each category. So I'm going to be giving a little less power to those 44, 25 to 39-year-olds and a little more power to those 35, 60 years or plus. Now, as mentioned, we have got a couple of ways of doing this. The older way, which uses a standard weight and is still very effective and works as it should do, but we also now have the use of a rim weight, which you could argue is overkill, as rim weighting tends to be used when you want to shuffle the data for two or more questions at the same time. I am going to be showing you both methods today though, more than anything just to show any existing users of the standard weights that rim weighting is there for using and does indeed produce the same end results and has some benefits along the way. Okay, so the first thing we need to do is to work out what actual data we have. Now, we've already got that because I've just produced my table of question 11 with question 12. So I'm going to keep that open, but I'm just going to save it and move it off to the side. And the first thing we need to do is open up the weights window. As mentioned, we use weights in Snap to perform a number of roles, one of which is for scoring data. So I've actually got a couple of weights already sat in here. If I open up WT1, weight number 1, this is going to be used to score a satisfaction type question from values 1 to 5. So very poor might be worth 1 point, very good might be worth 5 points, and for anyone that gave a sort of not applicable or no opinion, so option number 6 would be worth well, in fact, it's actually excluded from this calculation. Similarly, we have WT2, exactly the same idea. A negative or very negative option would be -2, a very positive option, +2. If you sat on the fence in the middle, it's going to be worth 0, and if you had no opinion or it was not applicable, you're going to be excluded. Today, though, we're going to be using weights to tweak our bases. So I'll just close those ones down, and we're going to create a new weight. I'll leave the name as WT3, weight number 3, and to work out the weighting structure, we need to take what we were hoping for and divide it by what we actually got. So for my first category, my 18 to 24-year-olds, I was looking for 40 people, and we actually got 40 people, so 40 divided by 40 is 1. So each of those 40 people will count as a whole person. I tab down. For the 25 to 39-year-olds, I was hoping for 40, but I actually got 44. So using a calculator, or if you're really, really good at maths, doing it in your head, but 40 divided by 44 is 0.909. So effectively, each of those 44 people will count as more or less 90% of a person. If we do the same for the remaining two categories, and again, I've already calculated these, so for the 40 to 59-year-olds, it's going to be 0.976. And then for the 35, 60-year-olds or more, each of those is going to actually count as 1.143 of a person. So effectively, each 25 to 39-year-old will count as 90.9 of a person. Each of the 35, 60-year-olds or more will count as 1.1 of a person. So some people will have more power, some people will have less power. Now, as mentioned, I am pretty good at counting and using a calculator when it comes to dealing with a couple of numbers, but just occasionally I might make a mistake, maybe type in the wrong number on the calculator. So what's going to be important is that we check to make sure these calculations are actually correct. And the easiest way to do that is to apply this weight, so WT3, to the table that we were basing the numbers on. So I'll save my weight, and if I bring up my table again, go into the properties, and we're just applying it in the weight at the bottom. So we've got WT3, which is the name of the weight, and we just need to confirm that that weight is going to be based on the data from question 12. If I click apply, you can see that's transformed my age data, so I've got a nice even match of 40, 40 and 40. It has also slightly changed the data for the gender question. So just to show you that again, I'll take off my weight. So you can see originally there were 80 men and 76 females. If I put my weight back in, it's adjusting all the data based on the fact that we've now got an even spread for the age question. So that was really just to check to make sure that my calculations were correct. What I can now do is take that weight and apply that to some other data. So I'm going to go and create a new table. And we're going to look at question 4A through to question 4D, which is a rating style question. I'm just going to turn that into a grid table. So this is my data based on the slightly mismatch of age groups. But if I was to now apply that weight, so again, WT3, but let's look at the data for question 4A, B, C and D if it was based on an even spread of numbers for question 12. And you can see the data's changed. Again, hard to tell what's changed, so what I'm actually going to do is open up another chart which I prepared already, AN3. So on the left hand side we have the original data with the actual data based on who actually responded to the survey. On the right hand side we have the data if it was based on a 40, 40, 40 and 40 spread for the age groups. As you can see, the weighted data has been adjusted, but not massively. And I think that's quite an important point. If after applying your weight your figures have completely changed, then it's quite possible that you need to consider whether your weighting matrix is overly aggressive. So have you given far too much power to a particular age group? Have you taken far too much power away from another age group? But in my example, you can see I've got 2, 10, 48 and 68, which is exactly the same. But then for the last survey good, I got 32 and 33. So we're just making minor adjustments. So we do need to be careful how we're scaling and why we're scaling. We're essentially editing the data that we've received, and as such we have got a lot of power in our hands. So for all the film buffs out there, with great power comes great responsibility. If you only receive 2 replies from the under 40s and then you just happen to speak to those 2 people when they're having a bad day, and then using weights you give those 2 people the power of 40 people, you're going to be making massive assumptions about those 2 people and assuming that they're representative of the other 38 under 40s that did not respond. In short, you're probably going to end up reporting that all under 40s are grumpy. If you actually received replies back from 37 under 40s, yes, you might end up with a fair number of grumpy people, but you're also likely to get quite a mix of differing views, and those 2 super grumpy people will then be diluted by the other 35 people. Using a weight to give those 37 people the power of 40 is then more likely to give you a true representation of the actual target audience. But it must be said that this is not an exact science and we are making assumptions with weighting. We are assuming that those that did not reply would have said the same as those that did reply. And for that reason, it's really quite important that we document that your data has been weighted and also justified why you did that. And just before we move on, we can see that actually in this particular table, we have the unweighted data and the weighted data. So we have got the options, if you wanted to go into properties, and under base and labels, we could actually turn off the unweighted line. So when I click apply, this top line is going to disappear. and we're just left with the base, which is based on the weighted data. Obviously, we do just need to be aware that there's nothing on this table now to say that this data has been adjusted. Similarly, if we look at a chart, so I'll just close these down and open up AN4. So we've got a bar chart of question 2. Again, I'll quickly add my weight. And if you keep an eye on these top two, they should change a little bit. So we've now got 27 and 20%. It is generally deemed good practice to include the base in charts so that people know what size this data is based on. In a chart of percentages, which is typically what's used when we're talking about weighted data, it would be the unweighted base that we want to display. So the base needs to show the actual number of people those results are based on to give them a sense of how reliable this data is. So to do this, I'm going to go into the notes and just add base, and then we can actually insert an analysis field. And if I initially insert the base, I'm just going to add the word respondents. Now if I click OK, so I've added some notes. What I haven't done is actually tell this chart to display those notes, because that's a sort of formatting option. So if I double click on the chart into my footnote, and I'm just going to make that now visible. So you can see it says that it's based on 93 respondents, but there weren't actually 93 people responding to this question. That 93 is based on the weighted data. So really, we want to insert the unweighted base. So again, back into properties and notes. And if I double click on base, instead of base, we're going to add unweighted. And you can see that's now changed to 91 respondents. Okay, so that was using a standard weight, which if you've weighted your data in Snap previously, I suspect that's probably how you've done it. Let's now turn our attention to rim weighting, which tends to be used when you want to weight on more than one question. You can do something similar using a standard weight, but this would be what's known as an interlocking weight, which is based on the values of a derived variable. So I'm just going to very quickly take you into my variables window, and I've got a derived variable called age gender. And that is based on the question 11 and question 12, so it's combining questions to create 4 subcategories. So we've got the males under 40, the females under 40, the males 40 or over, and then separately the females 40 or over. So it'd be a case of applying the weight to age gender rather than applying it to question 11 or separately applying it to question 12. But as I said, we're going to look at rim weighting, which looks at these 2 questions, but looks at them when they're not interlinked. So just close these down. And to do this, we need to go into the analysis of variables window. In here, I've already got a couple of variables. I've got an auto category variable, which is used for word clouds, and a group variable, which is used to sort of merge questions into sort of one combined question. But today we're going to create a new rim weight. I'll give it a name of age, gender, and rim. I couldn't just call it age gender because I had a derived variable with that exact same name a second ago. I'll just name it age rim weight for age and gender. Initially, I'm just going to add the age question just to show you that whether you use a standard weight or rim weight, ultimately it's going to be doing the same job. I'll leave everything as the default for the time being, and I'm going to build the weight. You can see it's automatically worked out that I want to have 160 cases and the split is even. So we've ended up with 40, 40, 40 and 40, which is exactly as the weight that we created manually earlier. I've saved that with the blue tick, and if I was just to bring up the chart that we looked up earlier, or the table, so AM1, so this was at the moment looking at the traditional weight that we created, WT3 earlier. If I swap that out for age gender rim, so the rim weight I've just created, click apply, and you should see that nothing actually changes. So that was just to prove that whether you use a rim weight or a traditional weight when you're doing your weighting, if you're looking at just one question, it really doesn't make any difference which way you go. But let's now introduce the gender question and look at some of the other options which are available. So we'll add a new question, and this time question 11. First of all, you'll notice that my data for the age categories has gone down to 39 for each of those, whilst previously we had 40, and that's because we're basing this weight on the valid cases, and we're also excluding any partial cases. And just to confirm, these are partial cases, not partial respondents, where someone has started the survey but they didn't ever get to the end and press submit. So these people did click submit, but in this example they didn't end up answering the gender question. So we've actually got 156 people, so there's 4 people that didn't answer that gender question. If I was to include the partials, you can see it's gone back up to the 160, and we have now got 40-40 across the board. But it's generally best to avoid including those partial data, so we will leave it on the exclude partial cases, which is the default setting. Let's have a look at some of the other options. So we have valid cases. Now this bases the RIM weight on the valid data responses to your actual survey, and the default ratio is 1 all the way down, giving an equal distribution for each of the variable codes. So I could start giving more power to one and less power to another, and the weight will automatically adjust itself accordingly. So for example, from a gender question, if I was to give the men 2, so at the moment it's a 50-50 split, you can see it's now gone to a 66-33, so it's gone up to 104 men and 52 women. If I make that now 3, you can see the figures adjust themselves again. But we can also add actual numbers there rather than ratios. So instead, I could perhaps say that I want 70 males and 86 females. What we just need to make sure is that these figures here, these numbers, add up to the same valid cases. If they don't add up to the same, so in my case, if I said that was actually going to be 90, so I've now gone over the 156, Snap will assume that you're not inserting the number of cases you want here, and it's now using this as a ratio. Okay, but either way, you're going to end up with 156 cases. I'll just pop that back to 86. From targets is another option. This lets you set the target number for each code, and again it's added under the ratio column. So for the gender, I could say I want 86 males and perhaps 92 females. And this time, rather than it turning it into a ratio or a percentage, it's worked out that because I'm doing from targets, I'm now going to end up with 178 people rather than the 156 that we previously had. I could then set some targets for the age question, or leave it as a default ratio of 1-1-1, so 25% across the board. But again, if I just adjust these, so again, I just need to make sure that the numbers I'm typing in here add up to the 178. As before, if not, if you go above or below the 178, it will just assume that these are ratios again. Final one is custom, and this allows you to enter a final sort of overall target. So this is really a mix of the two other options. So I could specify that I'm looking for a total of 200 people. You can then specify a total target and then allocate them below, adding them either manually as counts or as a ratio, or as a percentage. So I've got a ratio, and then for this one I'm going to do it as a percentage, so 40% and 60%. But I'm going to put mine back to valid cases, and I'm just going to build that weight. So I've got an even split for my age categories, but a 40-60 split for the gender question. Okay, a couple of other considerations, one of which is the tailoring settings. So in here we can state how many decimal places to work to, along with the maximum number of iterations you want the RIM weight to work on, and the match threshold for calculations. Now, unless you really understand your RIM weighting principles, it's probably best to leave them as they are, but in layman's terms we have the maximum iterations. This is kind of how many sort of shakes or wiggles of the data you want the rim weight to attempt as it tries to match up your targets. I guess the more variables you use, so today we've got sort of 2 variables, but if we had 5, 6, 7 different variables in here, it's more likely that the rim weighting tool is going to need to shake a little bit harder a few more times to try and match up these expected figures. We also have the rim weight assessment. Now, one thing in here which should be considered is the weighting efficiency. Weighting efficiency is a measure of how your survey sample, i.e. the people who've actually completed your questionnaire, compares to that of your target audience or your target population. It takes into account the amount of weighting needed to distort the actual data to get it to match up the ratios of your target population. It is a rather complex calculation that requires in-depth knowledge of statistics. I have spent a fair bit of time looking at it and trying to work out what on earth's going on, but I must admit I'm sort of none the wiser. And the good news is that the rim weighting tool within Snap is going to do this calculation for you. And as you can see, the weighting efficiency is presented as a percentage score. The higher the percentage, the less manipulation of the data has been needed, and the more your actual data was representative of the target population. The lower the percentage, the more biased your collected data was. In terms of what you're actually aiming for, so 90% or more means that your sample closely mirrors your population. Ideally, you're looking for a score of 80% or more. Less than 70% would suggest that you've got a significant bias in your dataset and you should perhaps reevaluate your weights. So it might be that you should consider excluding certain questions from your weight as the collected data is just too far away from what you're looking for. To give you an idea, if I was to say that rather than asking for 60 people, I'm actually looking for 100 females, and if I recalculate that and look at the weighting efficiency, you can see it's now gone down to 82. If I say that I'm looking for perhaps, given those the power of 160 people, you can see it's gone down even further. So it's gone down to 70%, which would make me think that perhaps I'm giving far too much power to those 76 females. But I'm going to pop my back to 1% ratio for the age categories and a 40-60 spread for the gender question. Again, that should bring my ratio or my weighting efficiency back up to 94%. Let's now have a look at applying this weight to some analysis. So remember, it's called age gender weight or age gender rim. So if I save that, I'll bring up AN4 again. So at the moment this has got the traditional weight, the WT3, which remember is just looking at the age question. If we now replace that with age gender rim, again looking at these figures 27, 20, so it's now 32, 18, 15. Again, if I take the weight out, that was the original data based on the 160 people that had filled in the entire survey. Obviously, again, not everyone's filled in this actual question. Pop my weight back in, and it's changed. Likewise, we can do exactly the same to our reports. So if I open up some reports, so I'm just going to make use of one of the summary reports which come pre-built into all our sort of surveys within Snap. So I'll double click on that one, and initially I'll just run it as it is. So this is the report which just gives us a sort of a bar chart for each of the questions. You can see for question 1 at the moment I've got 88 people and 72 people, and if I come down to the age question and the gender question, you can see I've got my sort of fairly even spread for the age question. But if I now go back into my summary report, and again I'm going to put my weight in there, so age gender rim, run my report. So if you can remember what the numbers were there before, so question 1 has changed, and just to prove it, you can see we've now got the 60-40 spread for the gender question and the 25% or 39 across the board for the age question. If we quickly go back to the weight. So in terms of advantages of using a rim weight rather than a standard weight, Well, first of all, you don't have to sit there doing your own sums to work out how much power to give each of my different age categories and gender categories. If you are going to be collecting data after you've created the weight, then the rim weight will actually update its calculations based upon the newly received data. So we just need to go in and basically run it. Whereas with the standard weight, each time you collected more data, it would be time to get your calculator back out to work out what you got versus what you were hoping for. And then obviously the major thing a rim weight does over a standard weight is the weighting of multiple questions at the same time. So it really is a far more advanced way of weighting your data. A few final thoughts and considerations. When weighting survey data, best practices involve minimizing the number of weighting variables. So avoiding extreme weights, ideally staying between 0.5 and 2 when setting your power, and carefully defining your target population to ensure accurate representation. Keep in mind though that upweighting data, so weighting something sort of 1 or above, so giving people the power of 1 or more people, is typically more dangerous than downweighting data, so weighting people below the power of a whole person. If your weighting factors are too big, then you might need to consider combining groups or just removing variables from the rim weight. By combining groups, I mean maybe combining the under 18s with the 18 to 25 group to create a sort of under 25 group, rather than massively increasing the few under 18s that did respond. We also need to avoid weighting questions which are directly linked to each other. So for example, if you had a question saying what's your annual income or your sort of your yearly wage, and you also have another question which is what size house do you live in, it's quite likely that the more money you make at work or whatever else you're doing to get money, the bigger your house is. And as I've said quite a bit today already, avoid large increases in values. So if you've got 96 males and only 4 females, you don't really want to be making it a 50-50 split, because you're just giving too much power to those 4 females and probably making huge assumptions. Remember, we need to use that power responsibly. Ultimately, weighting is a bit more subjective than people might think, because even though the outcome is going to be quantitative data, the figures are affected by which variables the researcher, as in you or I, have decided to include in that weight, and also what weighting limits we're prepared to accept. And sometimes there is a valid reason for downweighting your data more than what's deemed good practice. For example, a housing association might send surveys to 30% of the tenants overall, but include 100% of the tenants with a disability, because they are quite a small group, but they want to get enough data from those respondents so that they can analyse them separately. The collected data set is then going to be heavily biased towards the disabled population. It's then of course valid to downweight them to their natural proportions in the overall results. In short, if you can justify why you're weighting the data, then you're probably going to be okay. Okay, that's everything I wanted to show you today. A very quick recap of what's been covered. We've talked about why rim weighting is likely to be more useful than standard weighting. We discussed the reasons why you might use it, and hopefully I've stopped you from using it in a way that might be deemed unsavoury. And we've had a look at using those weights on individual tables and charts, and also how to apply them to your reports. On screen now are a few QR codes to take you to some further resources. The first 2 QR codes will take you off to a couple of pages on our support hub covering weighting and rim weighting. If you have got a spare 2 minutes, I'd be grateful if you'd complete the short survey about today's webinar, which can be accessed on the right. You will be receiving an email in the next day or so, which will include the links off to these resources, as well as the feedback form and a recording of today's session. Thank you for joining me, and we will hopefully see you again soon.